All right, guys, so continuing with our number properties, which we should already have this in our table of contents. So we don't need to add anything there, and we already added the notes to it. We are going to talk about another property today, a pretty important one, and that's the distributive property, which I think you're probably familiar with. Let me fix this just a smidge. There you go. Okay. So we need the distributive property when we have sort of multiplication and addition going on. Now, typically, if B and C were both real numbers, I would probably just add them and then multiply, like do what's in the parentheses first and then multiply by the number. But if I don't know B and C, or if they're not numbers that I can add up because they're not like terms, then I still need to multiply A to both of them, like the sum of them. And so we do this distributive process here where I take this number and I multiply it into both. So I multiply it by the first one and by the second one. And then if you're able to add, you can, and if not, that's okay too. And so I think you guys are familiar with this, but we're gonna try some. So if we open this up, I always find the arrows really helpful here. I'm gonna take this -5 that's out front, multiply it in to both numbers. So I draw my arrows, and what I end up with really slowly is -5 times 5x plus -5 times 7. And then we can multiply by whatever we want to multiply by. We don't have to be careful with multiplication. We just have to be careful with addition. And so -5 times 5 is -25. And then there's an X chilling at the end. And then -5 times 7 is -35. And I don't like to have two operations sitting next to each other. And the negative kind of is going to be there. So I'm going to leave this as a -35. Okay, if there are more things in the parentheses, I'm still going to distribute to all of them. So here I'm actually going to have 3 arrows because there are 3 numbers inside the parentheses. And so we want to make sure we distribute that 4 that's outside the parentheses to each of the numbers inside parentheses. And so very slowly, this looks like 4 times 2x plus 4 times 3y plus 4 times 10. Now again, we only have to be careful when we are adding or subtracting. Like if I'm looking inside those parentheses, I can't add those up. They're not like terms. But I can multiply whatever I want to multiply. So I can multiply all these by the 4 and I get 8x, 4 times 2. Bring down my plus sign. 4 times 3 is 12y. Now those are not like terms. So I'm not going to be able to add those. And then lastly, we have plus 4 times 10. 4 times 10 is 40. And that is not like any of the others as well because it's not an X or a Y. So you're just going to be left with 3 numbers like that. And I guess I'm going to box up my answers just so we know that we're done. And I know it sometimes feels uncomfortable to have kind of more than one number as our answer. I feel like in math, you guys always want to end with just one number as your answer, but that's not always the case. You might have more than one number as your answer, and that's okay. Okay, so another example here, we're going to distribute that 4 that's outside the parentheses to each number in here through multiplication. So 4 times 2x plus 4 times 6. And so again, we can multiply by whatever we want. So we have 8x plus 24, but I can't add those up because they're not like terms. One's an X and one's not an X. And then last but not least here, if I distribute this -3 to all of those numbers in the parentheses, we get -3 times x plus -3 times y plus -3 times 5. And again, this is one of those examples where I don't like to have 2 symbols next to each other, so we're going to have to deal with that. So -3 times x is really just like -3 times 1 with an x at the end, so -3x. Now here, the -3 times the y is -3y, but I don't want that next to the plus sign, so kind of the subtraction sign overrules it. So -3y. And then similarly here, -3 times a +5 is -15. And the negative overrules that plus sign, so -15 at the end, like that. And none of those are like terms. We have an x, a y, and a no letter, so we can't combine any of them. Okay, so then a little bit of a story problem. We're going to practice these some more later this week too, where we have to take words and make them into equations. So if you're a little shaky right now, that's okay. We'll go over it more. So a family of 3 each buy 2 oranges, x, and 5 apples, y. So we have this 2x and is a really good plus word, 5y. So we have 2x oranges and 5y apples, and then we have a family of 3 each buying them. So each of these, and each is a really good multiplication word, we're getting 3. So that's why this ends up looking like the distributive property. Each person in that family, so 3 times, is getting 2 oranges and 5 y apples. And so then we distribute. And maybe we can do this a little bit more quickly now. 3 times 2 is 6x. And then plus 3 times 5 is 15y. Okay, so the distributive property works even when I have subtraction in between. So we're still just going to draw those arrows. The only difference now, because this looks basically the same, is that instead of a plus sign in between, we have a subtraction sign in between. We just really need to be a little bit more careful because subtraction can sometimes be scary, or multiplying by negatives can sometimes be scary. So we'll go through. Maybe we can do these a little bit faster where I don't have to write the intermediate step. So like 6 times 5 is 30 with an x at the end. 6 times 7 is 42. Now, I have a +6 and a -7, and if you have a positive times a negative, then it's negative overall, or it's going to stay subtraction. Okay, and we can't combine those because one's an x and one's a non-x. On the next one, we're going to distribute 3 times because there are 3 numbers inside the parentheses, and we're distributing a -2 to each of those. So -2 times +2 is -4 with an x at the end. -2 times a -3. So a negative times a negative is a positive. So I'm going to make it a plus. And then 2 times 3 is 6, and then a y at the end. And then lastly, the -2 times a -10, because I always just take the sign with it. Negative times a negative is a positive. 2 times 10 is 20. And when I look through all of my terms here, none of them are alike. We have an x, a y, and then a no letter. So we can't combine any. Okay, on to the next. We distribute this 4 to each of the numbers in there. We're going to do 4 times 2 for 8 with an x at the end. And 4 times -6, a positive times a negative is a negative, and then 4 times 6 is 24. Those are not like terms because one is an x and one is a non-x. So that's as far as you can go. Okay, again, we're going to distribute this -3 to 3 numbers inside parentheses. Okay, so I kind of think about this in like 3 steps almost. Is it negative or positive? Number times number, and then what's the letter at the end? So on that first one, this is a negative times a positive, so it's going to stay negative. 3 times a 1 that's in front of that x is 3, and then an x at the end. Negative times negative on the next one, so negative times negative is positive. 3 times 1 is 3, and then there's a y chilling at the end. And then lastly, the -3 times the -5. So I have a negative times a negative, which is a positive. 3 times 5, which is 15. and then no letters at the end. And again, when I check, they're all different because I have an X, a Y, and no letter, so we can't combine any of them. Okay, so then at a lemonade stand, 5 cups of lemonade are sold at $1.25 each, but each cup costs 50 cents to make. So kind of like how much money you're earning here. Well, I sold 5 total cups, so 5 times the quantity of how much money I make. Well, I sell them for $1.25, but it cost me 50 cents, so I have to subtract that off. Now, here's a really good example of where I could do this problem one of 2 ways, because they are like terms inside here. Technically, I could do $1.25 minus 50 cents first to get 75 cents, and then multiply by the 5, and that would actually probably be faster here, but you can also times the 5 to each of these and then subtract afterwards. I usually don't recommend that though, so I'm not gonna do it. Those decimals. Okay, last but not least, we can distribute in whatever direction we want. So if we happen to have parentheses and then a number smashed up against the end of it, I still need to distribute that number into the parentheses to as many numbers are in there. Okay, so even if that number is behind and not in front, like this one is in front, this one is behind, still got to distribute. Still a thing I gotta do. Okay, so don't have a number up front, but back here I do have a 3, so I'm going to distribute that 3 into each of these. Positive times positive is going to be 15 with an X at the end. Positive times a negative is going to be a negative and then 21, because 7 times 3 is 21. Now those are not like terms, so we're not going to combine them. Okay, next one, I have a 7 at the end that's being smashed up against those parentheses, so I'm going to distribute that to all 3 of the numbers in here. And so a positive 2 times a positive 7 is 14 with an X at the end. Next, a positive 3 times a positive 7 is a positive 21 with a Y at the end. And then lastly, a negative 10 times a 7 is going to be a negative 70. And when I look through, they're all different, X, Y, no letter. So I can't combine any. Okay, 3 more, we got this. So here I have a 4 smashed on the end of this parentheses, so we're going to distribute that to both. We always distribute through multiplication, so 4 times 2 is 8 with an X chilling at the end. And then 4 times 6 is a positive 24. So I should note, like, you're always going to end up with a string of numbers being added or subtracted. So there's always still going to be a plus or a minus sign in between these. We just multiply the outside number to each of the inside numbers. So that's important to kind of understand. You're not going to end up with probably just one number here. Okay, so last one. My face is kind of covering it. There we go. You're going to distribute that 3 that's smashed up on the end, and you're going to multiply that to each of the numbers in here. So 3 times X is 3X. 3 times negative Y is negative 3Y. And then 3 times negative 5 is negative 15. And I can't combine any of those because one's an X, one's a Y, and one's a no letter. So they all have to stay separate. Okay, and then that last little story problem there. At a party, each person takes 2 slices of pizza and 3 pieces of candy. There are 10 total people. So if we think about this, 2 pizza pieces and 3 candy pieces is taken by each person, and there are 10 people to find the total number of pizza and candy that's taken. Like that. So hopefully that kind of makes sense. And then we would distribute that 10. Now, technically, I guess it goes at the end because they said 10 people, but it doesn't matter because we can multiply in either order because commutative property from, the other day. So, okay, I distribute that 10 and we get 10. Oh my goodness, times 2p. Oops, that's all right. We'll write it slow. Also, it's behind my face. There you go. And then plus 10 times 3c. And 10 times 2 is 20 pieces of pizza, plus 10 times 3 for 30 pieces of candy, and hopefully you have enough to keep your party goers happy. Alrighty, let me know if you have any questions and try out that Google Forms and hopefully it goes okay.